So this is more about your practice. Okay. So another example. F of x1 comma x2 is 1 by x1 x2 on R plus plus 2. So check whether this function is convex or not. So what do you get? Yes, guys. Solving or just waiting for me to solve it?
So is there any additional constraint like x2 greater than x1 or something?
Why do we need such constraint? That really help. Hmm? What is the Hessian you are getting? Tell me. Based on that, maybe I will be able to help you.
1 upon x2 x1 cube.
Just a second. Yes.
minus 1 upon.
What is the Hessian? Go ahead.
2 cube.
Minus 1 by x1 square x2.
I'm asking what Hessian, not determinants.
So it is 2 by x1 cube into x2 first term, then 1 by x1 square x2 square,
x2 square.
then
Again
1 by
1
x1 square
square.
x2 square, then 2 by x2 cube into x1.
This is the Hessian you are getting? Both
Yes,
x1 and x2 positive from here. Now we need to check the whether it is positive definite, positive semi-definite or what. So let's look at the each one of them. So D1, which is 2 by x1 cube x2. Is it positive or negative?
positives.
In fact, what you can do to make it more, take 1 by, how much I can take x1 and x2 outside. Take 1 by x1 and x2. Then we are left with 2 by x1 square, 1 by x1 x2, 1 by x1 x2, and 2 by x2 square. Is this right, guys? This guy is positive, because both of the variables are positive. Now let's look at D1. D1 is 2 by x1 square, which is positive. D2 is, how much is D2? Determinant of that minor. 2 into 2, 4, x1 square into x2 square minus 1, x1 square into x2 square, 3 by x1 square, x2 square. So, who has asked that question? What is the importance of x, whether x1 is greater than x2 or less than x2? Does it make any difference? Praneeth?
No sir, no sir. I took in the finding the determinant. I kept some
Okay.
x1 x2 differently.
So,
I
is this greater than 0?
Yes sir.
So, both D1 and D2 are greater than 0. So, what is the nature of the matrix?
Positive definite.
It is positive definite. It is positive definite. What it is? Convex, strictly concave, convex, concave, strictly concave. Strictly concave, right? Sorry, convex. Does this make sense? क्या हो गया? Page. Yeah. So is it convex or strictly convex? What is the theorem?
Positive semi-definite is
Oh, I'm sorry, I missed this part. I'm so sorry, I missed this part. There is one more theorem. I have not taught you actually. I'm just writing this one. That was part of the last theorem. Theorem 4 is let S be a non-empty convex set in Rn and let F S to R be twice differentiable on S. Okay, if the Hessian matrix is positive definite at each point on S, then F is strictly convex. Conversely, if F is strictly convex, then the Hessian matrix is positive semi-definite. Positive semi-definite at each point in S. However, if F is strictly convex and quadratic, then its Hessian is positive definite. Sorry, I missed that part. I thought I have covered it. So definitely yesterday we talked about the convex function. This theorem tells you about the strictly convex function. Just read it. There are some interesting points. I will try to explain it with one of the example. So what it says that if a function on a non-empty convex set, if it is twice differentiable, and if you find Hessian matrix to be positive definite at each point on S, then F is strictly convex. I'm not talking positive semi-definiteness, but positive definiteness. Conversely, if a function f is strictly convex, then the Hessian matrix is positive semi-definite at each point in S. So if you find a Hessian matrix that is twice differentiable, then you can say the function is positive definite. But if you have a convex function, then if you have a strictly convex function f, then Hessian matrix, if you find, it will be positive semi-definite at each point in S. So, however, if f is strictly convex and quadratic, then its Hessian is positive definite. So let's just look at the simple example of fx equals to x square. So f dash x is 2x and f double dash x is 2. So it is strictly convex or convex only? What, you guys do not have any energy today? Generally it is an excited class, enthusiastic one.
Strictly convex, sir,
Why?
because it is a positive definite.
So it is positive definite. It is not greater than equal to 0, but greater than 0. So definitely it is strictly convex. Now look at fx equals to x to the power 4. What happens to this one? F dash x is 4x cube. F double dash x is 12x square. F triple dash x is 24x and f4x is 24. What can you say about this function? What can be said about this function?
It is convex
Hmm?
because f double dash x can be 0.
I'm sorry? Right? At x equals to 0.
Yes.
So definitely I can say f double dash x is greater than equal to 0 for all x belonging to real number. Is this correct?
Yes, sir.
Now, interesting thing here is that I will discuss the next theorem based on this. We can lose positive definiteness of a function at finite number of points and still be able to claim it as strictly convex. So what we are trying to say here is, suppose if I look at f double dash x except 0, everywhere else it is positive definite. You agree?
Yes, sir.
Whether it is negative or positive x, it is satisfying the criteria for strictly convex function.
Yes, sir.
Am I making sense, guys?
Yes, sir.
Yes, sir.
Except 0, f double dash x is greater than 0 for all x belonging to R. there is only one point x equals to 0, it is losing its positive definiteness. Okay, so next theorem we will discuss. We can lose positive definiteness of a function at finite number of points and still be able to claim it as a convex function. Definitely, if I'm able to show that Hessian matrix is positive definite, we can always say it is strictly convex. But if it is a strictly convex function, we know that its Hessian matrix will be same positive semi-definite at each point. Even at x 0, f double dash x is greater than equal to 0, we can say, right? It satisfies the criteria for positive semi-definites. So f is strictly convex, then the Hessian matrix is positive semi-definite, we can say. Further, if I get the positive definiteness, definitely it is strictly convex function. So based on that, what is this function? It is strictly convex.
Yes, sir.
Now let's try another example. Example 4. Over what domain is the function fx equal to x square into x square minus 1 convex? Is it strictly convex over the region S? Over the region specified? Or concave? So look at this function. Tell me where it is convex, or is it strictly convex, or what it is.
Sir, for x greater than 0.4, it is strictly convex.
Can you give me in reciprocals?
Sir, 1 by root 6.
Okay, so you are saying x
Greater than
Greater than 1 by root 6.
greater than
1 by root 6.
greater than 1 by root 6. It is
Strictly convex.
Strictly convex.
strictly convex. Anything else?
X less than minus 1.
Both plus and minus 1 by root 6 when x is.
Yeah, tell me. So what you did, you got the f double dash x equals to 12x square minus 2. This is what you got for double dash x.
Yes, sir.
Yes.
This should be greater than equal to 0 for it to be convex. Agree? So you get two regions, S1 where x is greater than equal to 1 by root 6 and S2 where x is less than equal to minus 1 by root 6. Is this correct? Over this region, it is convex or strictly convex?
Sir, convex.
Over this region, it is only convex. Because your f double dash x will be greater than equal to 0, right?
Yes, sir.
Over what region it will be strictly convex? What you were telling me earlier, x is greater than 1 by root 6 and x is less than minus 1 by root 6. It is f dash x will be greater than 0. So positive definite. So strictly convex. Does this make sense?
Yes, sir.
So can we say the complete function itself is strictly convex? So what we have is 1 by root 6, sorry, minus 1 by root 6, 1 by root 6. In this area, we are calling it to be convex. In this area, we are calling it strictly convex. So can we conclude that it is strictly convex throughout?
No, sir.
Why?
Because it is not strictly convex at the 2 points, minus 1 by root 6 and 1 by root 6.
No. Foregoing theorem which we have said that we can lose positive definiteness at few points and still call it strictly convex. Based on that, can we say that function is strictly convex?
Sir, how
Sir,
can we?
it is not strictly convex in the between region.
Between.
Yes, sir.
अच्छा हमने उल्टा कर दिया, sorry. X is greater than, this is other way. This is convex and this is strict. Is it right now?
Yes.
X greater than 1 by root 6, it is strict. X less than minus 1 by root 6. X greater than equal, no.
Sir, only at the exact points of 1 by root 6 and minus 1 by root 6, excluding that, it is strictly convex, and including that, it is convex. Is that correct?
So can we conclude that the function is strictly convex because we are losing the positive definiteness at few points? Is this correct? Yeah, your opinion, your thoughts on it. At what point it is losing its positive definiteness?
Sir, between minus 1 by root 6 and 1 by root 6.
So actually it is not just one point or finite number points. Between minus 1 by root 6 and 1 by root 6, how many points are possible?
Many points.
Infinite points. So we cannot conclude that it is strictly convex over the complete region. What we can only conclude that it is strict convex in this one and convex on this part. Does that make sense, the importance of that theorem now?
Yes, sir.
You have to keep in mind finite number of points or countably finite, not only finite, countably finite. Okay.
So how for infinite points it is losing positive definiteness? Because at
Because
only 2 points it is losing.
By root 6, how many points are there?
So for in between, if we exclude minus 1 by root 6 and 1 by root 6, for all other points you can say that it is strictly convex, right?
So I'm saying between minus 1 by root 6 and 1 by root 6, how many points are there?
There will be infinite points.
So am I losing my positive definiteness there?
No, sir.
We are not losing.
Yes, sir.
What is happening between these 2 points?
Between these 2 points also, if we exclude those 2 points, we can say that it is strictly convex.
Is it?
Sir, f double dash x is not greater than 0 in between this region.
Yes, sir.
I'm not sure what you are asking. What is happening between 1 by root 6 and minus 1 by root 6, Monigini? Monimingi. Sorry, how do you pronounce your name? I keep pronouncing it.
My name is Moningi Srivalli.
Moningi Serivali, yeah. So what happened between minus 1 by root 6 and 1 by root 6? Is f double dash x greater than 0?
Should be greater than 1 by f double dash x.
Any point between, forget about anything, just put f double dash
Sir, we can
where
take
x equals
0.
to 0. Just put x equals to 0, yeah. What it is.
Okay, I understood, sir. I understood, sir. I got it.
Got it?
Yes.
Okay. One more example from composite function point of view. First, we will just write it as we know how we solve composite. Source composite function is convex. So let g, a function g, Rm to R be a convex function. H Rn to Rm be a affine. Just a second. I think I have missed something here. This does not look right. Okay. Be an affine function of the form hx equals to ax plus b, where a is m cross n and b is m cross 1. So that composite function f Rn to R defined as f of x equals to g of hx is a convex function. So I need to show a composite function which is comprises of one of convex function and one affine function. And as I said, affine function as needed, you can use it as a convex function, you can use it as a concave function. Okay. So go ahead, try to prove this. So what is the general route we generally take to prove this?
X equal to lambda x1 plus 1 minus lambda x2.
We need to say here something more. You have to say x1 and x2 be any two vectors here. Okay. Because you see your affine function is defined in terms of m cross n and m cross 1. So in Rn, and then you define your x as lambda x1 plus 1 minus lambda x2. Is this correct, Abhijit?
Yes, sir.
Then I need to somehow show that f lambda x1 plus 1 minus lambda x2 equals to g h, sorry. What we need to show is this is less than equal to lambda fx1 plus 1 minus lambda fx2. This is what we need to show.
Yeah.
So let's start with this left hand side. We can write this as g of h lambda x1 plus 1 minus lambda x2. Is this correct?
Yes.
Now h of lambda x1 plus 1 minus lambda x2, given that it is an affine function as you want, you can use it. So it should be simply be equals to lambda ax1 plus b plus 1 minus lambda ax1 x2 plus b. Can we write this? So h lambda
Yes.
x1 plus 1 minus lambda x2 is nothing but lambda hx1 plus 1 minus lambda hx2. Let's plug this in here. We really need to simply
So
write it.
we can little bit simplify it.
Just write it. We don't need ax1 and ax2. I will use
Yes.
it later. We can simply say it is lambda h of x1 plus 1 minus lambda h of x2. Okay. Since g is convex, I can always write lambda g h of x1 plus 1 minus lambda g h of x2, which is nothing but this is equals to your lambda fx1. This is 1 minus lambda fx2. Okay, so this is the conventional route we take. Now I tell you g is twice differentiable. So I'm on top of what I have given you on top, I'm also adding this line. if you knew this part, how would you have approached this problem? Similarly, or the same way, or little different? Knowing that f is twice differentiable, is it helpful or not? Who will help me? Mayank? Mayakla? Prithvi? Let me see what our BTech guys are doing. Sukur? So as expected, given 8 AM class, most of our BTech friends have decided not to join. I can see it here. Good. Seems I have to make attendance compulsory. Anyway, guys, how would you proceed this? कुछ तो बोलो, गलत ही बोलो. How do I differentiate this one? Can I write g dash h of x to h dash x? Is this correct, guys?
Yes, sir.
What is h dash x? Simply a.
Yes.
So I can write a g dash hx. Then again differentiation of this one. So d double dash hx into h dash x. What do I get? A square g double dash h of x. Is this correct?
Yes, sir.
All of you.
Yes, sir.
Bharat, you agree?
Yes, sir.
Yes, sir.
Okay, so based on this, can we say it is convex? So a square, will it be always greater than equal to 0?
Yes, sir.
Whether a is negative or positive does not matter, right?
Yes.
What can I say about g double dash hx? Is g a convex function?
Yes, sir. G convex.
Yes, sir.
So what happens to its Hessian?
Greater equal to 0.
So both the quantities are greater than equal to 0. So f double dash x is greater than equal to 0. So can we conclude that it is a convex function?
Yes, sir.
But why I did not do this when I was just looking at this part of the problem? Why did not I use this strategy to show it is a convex function? Because nowhere it was given that it is a convex function, right? Sorry, it is a twice differentiable. So keep that in mind. When if I ask you any question and I have not discussed anything about differentiability, do not show me the second order differentiation or Hessian and say that okay, we have a convex function. Agree? Until unless the problem states that it is differentiable or twice differentiable, then only we can use what I have done on the later part. Otherwise, we have to proceed in the form in a way we prove the Jensen's inequality. Is this clear, guys?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so I stop here. We'll continue next week. I hope we are not losing any class next week. Wednesday we do not have any class, right? Okay. So Wednesday we are not losing any class. So most probably I will be able to complete the convex part next week. Okay, if you have any questions, we can discuss it now. Otherwise, thank you very much, guys. I will see you next week.
Hello, sir.
Yes.
Can you explain that HX part?
Which part you want me to explain?
Sir, the last thing.
What do you think? How can we take that as a, just a second, let me just get this. Yeah. Bolo.
Roll up, sir. Just HA,
Okay.
the right side part.
Yeah, exactly. What do you want me to explain here? That's then only I have written everything. Tell me what, have I missed something?
Yes, sir. That you did the convex combination of lambda x1 and 1 minus lambda x2 in HX.
Which one? The first part or the second part?
Yes, sir.
Uh,
First part.
first part.
Yes, sir. Yes, the
This
right
one.
side is h of
Yeah.
lambda x1 plus.
1 minus lambda x2.
Yes, sir.
So can we write it like this or not?
Yes, that's what I'm not getting, because if we take lambda x1 plus 1 minus lambda x2 as a
Okay.
whole x,
Let me cut this. Can I write it like this? H
Sir,
of lambda x1
before the second line, before the second line, we can introduce another line as a lambda x1 plus 1 minus lambda x2 plus b. Then the second line will automatically come, and then the third line.
Okay, let me just forget about it is of the form ax1 plus b, Abhijit. Let's say h lambda x1 plus 1 minus lambda x2. Can I write it like lambda hx1 plus 1 minus lambda hx2? Who was this? Praneeth, you were asking this question?
no, Harshit, sir.
No, sir.
Harshit.
Harshit.
Yeah, Harshit. Harshit, can I write this h lambda x1 plus this part?
That's what I'm not able to get.
So for that part, have you attended the class from the beginning?
Sir,
What we have discussed about the affine function, it can be used as convex. It is both convex and concave, right?
yes.
So if it is convex and concave, can we not write this?
Yes, sir.
See, in case of affine function, we have, when we were showing you, I showed you that because of the equality, in fact, ax1 plus b can be used to show that because of the equality, it is both convex and concave at the same time. Using that fact that it is an affine function, I have written this and then I have plugged it in here. You can go through the notes where we have discussed, started the convex function. You can see the affine function there. Okay.
Okay, sir. Once I get it through, I will ask you again.
Sure, anytime. That's why I'm here, man.
So can I ask a question?
No. Of course you can ask. Go ahead.
Sir, actually, this proof, will it hold good if means this will be same even if x1 and x2 are not vectors? How this x1
Actually,
x2 being
see,
vectors?
the way the problem was given, we have to call it vector. Otherwise, it is just a point, right?
Yes, sir.
What x plus b is given you set of 3x1 plus 2 3ax1 plus b 2 equals to some. This is the kind of functions we are getting. 3 2 1 3 4 2 and then it is multiplied with some a comma 1. Okay. So it should hold. Even if it was not a vector, I would have said R into R. That was fine.
So can you repeat this? It's not.
Even if instead of I'm showing hx of the form ax plus b, which is a, let's say like in linear programming. Linear
Yes, sir.
programming, we have ax equals to b, right?
Mm.
That kind of situation. So there we do not have just one x, but your set of equations or inequations. Based on this, we find the feasible region, right?
Yes, sir.
So that is what I'm saying, that even if the question was R into R instead of R into Rm, I was just talking about one Hx. Here, Hx has a m by n structure to it.
Okay, sir.
More precisely, suppose if I'm putting ax plus b equals to 2. So if I take it there, ax is equal to 2 minus b. So it is of form ax equals to c.
Yes, sir.
Got it?
Yes, sir.
Any other questions, guys? This is lecture 6 na, as per the files I have uploaded. Lecture 5, lecture 6. Yeah, meanwhile I'm uploading, you can ask any questions if you have or any doubts you have.
So the last lecture, I think it is not uploaded. Last Tuesday.
No, I told last class now I will upload it today after completing this example.
Yes,
So
yes.
lecture 6. बहुत दिक्कत है इसमें. So many times, sometimes upload fail. If you notice that, just drop a message in the general chat so that I upload it again. Okay, guys, thank you very much. I will see you next week. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.